Hi, it's time for more calculus. Woo! Woo woo! So here we go, let's do this. Rewrite the function as a function in polynomial form. So what that means is I'm going to make it look like some number times a variable raised to an exponent. So if I do that, I get f of x is equal to 2x cubed minus x squared, or I'm sorry, not minus, divided by, but I would subtract the exponents because they have like basis. So this would be 2x minus 3x squared divided by x squared is just going to be 3 plus 2 over x squared, which I'm going to write as 2x to the negative second power. This is the same thing as saying x to the 0 power, so I would still subtract the exponents and I would get this. If I take the derivative, I get f prime of x is equal to 2 minus, this would be 0, so I don't have to do that. Negative 2 times 2 would be negative 4x, subtract 1 from the exponent. I'm going to rewrite this. This is the derivative right here, but I'm just going to rewrite it to make it a little bit nicer. So I have 2 minus 4 over x to the third power. And then I'm going to do one more thing so I can get this to have a common denominator. And normally you wouldn't have to do this, but I'm doing it right now just because I want to, well, I've got a plan down here. So I need this to have x to the third. I can't just divide by x to the third all willy-nilly. So here I'm going to say x to the third here. So I'm multiplying by some crazy formula 1. When I do that, I now have a common denominator of x to the third. So I can say 2x to the third minus 4. And this totally works out, and I am allowed to do this, to say this is my derivative by just doing the power rule. But there are going to be some times when we can't do that. And so there are going to be some times when we have to use what is called the quotient rule. Just like the product rule made sense, the name of the product rule was just if you're multiplying two functions together. For quotient rule, it's if you're dividing. And so I'm going to use the same d dx, the u and v that I used before, but I'm going to say at a point where v does not equal 0, because I'm going to end up dividing by 0 and you can't divide by 0, where v does not equal 0, the quotient u divided by v of two differentiable functions, so meaning u is differentiable, you can take the derivative, and v is differentiable. I'm going to say whatever I get is differentiable, meaning my result, you can also take the derivative of, that quotient you can take the derivative of, and d dx, meaning the derivative of u divided by v, is bottom, so v, times the derivative of the top, so dx, du dx. So bottom times the derivative of the top minus the top derivative of the bottom, so that's the dv dx, over the bottom squared, or v squared. And I'm going to write that on the side. This is bottom times the derivative of the top, so I'm just going to say top prime, minus top derivative of the bottom. Oh, I'm going to run out of room. I just put bot over the bottom squared. So bottom derivative of the top minus top derivative of the bottom. And order is important here. So bottoms up, but be careful. Never drink and derive. Know your limits. It's a slippery slope. Okay, I'm done with that part. Maybe you'll come back with puns later. Who knows? If you're lucky. To show that this works, I'm going to take this same function that I did up here, and I'm going to use the product rule, or I'm sorry, the quotient rule. Silly me, products are only for, the product rule is only for products. This is a quotient. So I'm going to say this is f prime of x. I take the bottom, which is this x squared, so bottom, times the derivative of the top would be 6x squared minus 6x. The derivative of 2 is just 0. Bottom derivative of the top minus the top. So make sure you use parentheses. Times the derivative of the bottom over the bottom squared. X squared squared is x to the fourth. And you're like, this looks disgusting. It does look disgusting. So I would probably actually do this one just using the power rule like we did in the first one where you simplify first. But that's okay. I'm just going to keep going for a second. This would be 6x to the fourth minus 6x to the third so I'm distributing that, minus, I'm going to take 2x, and there's a negative here, and I'm going to distribute those, so this would be minus 4x to the fourth, plus 3 times 2 would be 6, there's a negative to negative, 6x to the third, plus 4x all over x to the fourth. Simplify this, f prime of x, 6x to the fourth minus 4x to the fourth would be 2x to the fourth. This x to the third will go away, that's good, plus 4x over x to the fourth. And you might be thinking, that's not what I got up here. But if you factor out an x, I can say this would be x, 2x to the third plus 4 over x times x to the third. Now this is exactly the same thing that I got here. So the product rule, I'm doing it again. Oh my goodness, it's like calling somebody by their sister's name. Now, the quotient rule works. We did it. And you might be saying, well, why don't we do the power rule all the time when we can't, change it into the polynomial and do the power rule? Well, right here, 2x minus 1 divided by x plus 3, I can't actually divide anything. I can't separate this and say 2x divided by x plus 3, negative 1 divided by x plus 3. Well, I could, but it's still not going to work. So I can't do the power rule. So what do? I have to do the quotient rule. This one says find the equation of the tangent line, which I'm not even starting out with just finding the derivative. I'm doing the equation of the tangent line. It's like coming back to an old friend. In order to do the equation of a tangent line, I need two things, a slope and a point. To find the slope of a tangent line, you need to find g prime. And then say the quotient rule to yourself. Start bottom times the derivative of the top minus top derivative of the bottom over the bottom squared. So I'm going to say bottom is x plus 3 times the derivative of the top, which that would just be 2, minus top, 2x minus 1, times the derivative of the bottom, which is just 1, over the bottom squared. You know how I simplified up here and did a bunch of stuff? I don't want to do that. I just want to say, well, what is g prime of negative 2? Negative 2 plus 3 will be 1 times 2 minus 2 times negative 2 minus 1, so negative 4 minus 1 is negative 5, over negative 2 plus 3 would be 1 squared, and I would get g prime of negative 2. This would be 2 plus 5 is 7 over 1, and I get 7 as my slope. So I know y minus y1 is equal to m, which would be 7. X minus x1 would be minus negative 2. All I need now is my point. My point is just going to be g of negative 2. So I go up here and I say 2 times negative 2 minus 1, negative 2 plus 3. Get 1 in the denominator. Negative 4 minus 1 is negative 5. So negative 5 is my y value, which would be plus positive. Did it! Woo! So exciting. Let's keep going. More math, more math. Is that what you're saying? Somebody else chanting? No, it's just you chanting. Okay, so then you're thinking about this and you're like, well, I know other things that have quotients in them. Can we do trig today? We can, because if I want to find the derivative in here, it says use the quotient rule to derive the derivative formulas for the remaining trig functions. So if you remember, tangent can be written another way. Tangent can be written as sine of theta over cosine of theta. That looks like a quotient to me. So f prime of theta would be bottom times the derivative of the top. The derivative of sine is cosine. Bottom times the derivative of the top minus top. The derivative of the bottom, the derivative of cosine, is negative sine over the bottom squared. Okay, let's keep going. F prime of theta is equal to cosine of theta times cosine of theta is cosine squared of theta plus sine squared of theta. Oh, this is exciting. Over cosine squared of theta. The reason why I say this is exciting is because sine squared plus cosine squared, or cosine squared plus sine squared, is actually equal to 1 according to the Pythagorean identity. Remember, 1 over cosine is also known as secant. So the derivative of 1 over cosine squared would just be secant squared. So really, if you're like, I don't want to do all this work all the time, and I just want to know that the derivative of tangent is secant squared, you're going to want to know that. So this is one, make a flashcard for it, and then say, okay, I've got this. The derivative of tangent is secant squared. You need to have this in your head. What's the derivative of tangent? It's secant squared of theta. Don't forget that. You always need an angle. Okay, let's try another one. So cotangent, I'm going to rewrite, I'm going to write f of theta is equal to cotangent. I'm going to write, you can either write 1 over tan or you can write cosine over sine. I'm going to stick with that one. It doesn't matter which one. So you could have done 1 over tan and then derived that. F prime of theta is going to be the bottom. So sine of theta times the derivative of the top. The derivative of cosine is negative sine. Minus the top. Derivative of the bottom is cosine of theta over the bottom squared. This one, I'm going to have negative sine of theta, but squared, everything, minus cosine squared of theta over sine squared. This one is pretty close to what we want as far as the Pythagorean identity is concerned. So what if I factor out a negative, and then this becomes positive and positive? Now the numerator is just negative 1 over sine squared of theta. Do you remember what 1 over sine is? 1 over sine is cosecant. So the derivative of cotangent is negative cosecant squared theta. Let's do another one. I want a different color because I can. Do you see how fancy I am? Maybe I'm not fancy. Maybe I shouldn't have said that because the only color I see right now is yellow. Oh, nope, I got pink. Woo! Magenta for the win. Secant is also known as 1 over cosine. If I do the quotient rule, bottom, ooh, this is nice, times the derivative of the top. The derivative of 1 is 0. Minus the top. The derivative of the bottom, the derivative of cosine, is negative sine over the bottom squared. So this will go away because anything times 0 is going to be 0. This would become positive, so I have sine of theta over cosine squared. So I'm just going to tell you cosine squared is the same thing as cosine of theta times cosine of theta. And the reason why I want to say that is because when you're taking the derivative, when I ask you what's the derivative of secant, this is a correct derivative, but more often it looks like this. F prime of theta is written as 1 over cosine of theta times sine of theta over cosine of theta. That, if I simplified it, 1 over cosine is the same thing as secant of theta. Sine over cosine is tangent. So we've got this derivative that is secant tangent. The last one, and you could try this one too. What do I want to go back to? I don't want to search for more colors. I'm going to go back to green. F prime of theta. If I rewrite cosecant, I'm going to write that over here as f of theta is equal to 1 over sine. F prime of theta then would be bottom times the derivative of the top. The derivative of 1 is just 0. Nice. So bottom derivative of the top minus top derivative of the bottom. The derivative of sine is cosine over the bottom squared. Sine squared looks a whole lot like the other one so far, or at least some similarities. This goes away, and I'd be left with negative cosine of theta. And again, I'm going to change this into sine of theta times sine of theta And then I'm going to rewrite this one as negative cosine of theta over sine of theta times 1 over sine of theta and then just because this is normally written first, 1 over sine of theta is cosecant. And then over here, cosine over sine is cotangent. Cotangent theta times cosecant theta would be totally correct if I remembered this negative sign. But it's often written, if I say, what's the derivative of cosecant? Most people would write cosecant, cotangent. Like, it's just often in that order. But if you said cotangent, cosecant, as long as they were negative, that's fine too. Okay, so that took a while, but really all you have to know on these is this final result. So if you can memorize these, so make yourself some flashcards. So stop the video right now, find some flashcards, write it on a piece of paper on one side. F of theta is tangent of theta. The derivative then is secant squared. The same thing with all these other ones. Just have this in your head and it will be very helpful. So let's do another one. This one says, write the equation of the normal line. Hey, the normal line I know is perpendicular to the tangent line. So if it's perpendicular to the tangent, I should probably find the slope of the tangent line. So f prime of theta is going to be the bottom cosine of theta times the derivative of the top, which is just 3. Think about this as 3x. Bottom derivative of the top minus top derivative of the bottom. The derivative of cosine is negative sine over the bottom squared. And I'm just going to simplify this enough that it's a little bit easier for me to write. So this would be negative would be a positive 3 theta sine of theta over cosine squared. Now this is going to get gross real quickly, and so what I'm going to show you on this, f prime of theta, f prime of 2 pi over 3, be cosine of 2 pi over 3 times 3. Do not multiply this by 3. This is just saying, there, I can do that. The 3 goes out in front afterwards. Minus, this one would be 3 times 2 pi over 3. So this one is okay. 2 pi over 3. So these 3's would go away. Oh sorry, this one should have been plus, because plus over here. I think I went up to there for a second. Sine of theta, so sine of 2 pi over 3. And then I would have cosine of 2 pi over 3. And whenever you're squaring something like this, you square the final answer. So much trig. I know you're really happy right now. And if anyone's watching and they're like, wow, they're so smart, look at all this crazy stuff, that's okay. Okay, so take a moment. If you need to go back and review another video of how to find these angles, you can do that right now. But cosine of 2 pi over 3, and this one, I should get, actually, I can do this right here because I think there are enough people that might need this. If I say this is pi over 3, this is pi over 6. In my mind, what I do is I say, okay, this is pi over 6. This side, it will be square root of 3, and this side will be 2. Cosine of 2 pi over 3. I'm using this reference angle of pi over 3. And then I'm saying, okay, this would be adjacent over hypotenuse, so 1 over 2. So I have 3 times 1 over 2. But then I'm thinking, what quadrant is 2 pi over 3 in? So if this is 0, and then it goes the whole way, this is pi over 2, this is 3 pi over 2, and then this again will be 2 pi. 2 pi over 3 is 2/3 of the way around. So I'm going, this is halfway to pi, 2/3 of the way from pi would be in this quadrant. All students take calculus, or awesome students take calculus. Sine is the only thing that's positive, which means cosine is negative. So I have 3 times negative 1/2 plus 2 pi over 3. Sine of 2 pi over 3. So I'm going to do the same thing. I'm using pi over 3 as my reference angle. Now I'm going to say opposite over hypotenuse, and I get square root of 3 over 2. I can see sine is positive in that quadrant, because again, it's 2/3 of the way to pi. So this stays positive. Cosine I already know of cosine of 2 pi over 3, we just found out it was negative 1/2, and then I would square it. I'm not going to simplify this much. This is going to be real gross, but this would be negative 3/2 plus, I can do just a little bit, plus pi root 3 over 3 over 1/4. If I wanted to, I could take this, and instead of dividing by 1/4, I can multiply everything by 4 over 1. So 4 over 1 in the numerator, 4 over 1 in the denominator. Dividing by 1/4 is the same as multiplying by its reciprocal. So I can say that f prime of 2 pi over 3 would be 4 times negative 3 over 2 plus pi over root 3 over 3. And then I'm going to leave it there. So even though this looks disgusting, I found the slope of my tangent line. This says the equation of my normal line. So I would say y minus y1 is equal to m. So my m is the opposite reciprocal. So I'm going to say negative 1 over this whole mess. And yes, it's okay to simplify this in some way. I think my answer before has, I'll show you it in a second, because I actually multiplied these out, and that would be totally okay if you distributed this form. But you could have actually left it kind of like this and just did the opposite reciprocal. It just looks disgusting. But this would be my slope of my normal line, because it's the opposite reciprocal of the tangent line. I'm going to say x minus my x1 was 2 pi over 3. My y1, oh, let's go back here and do it. I know f of 2 pi over 3 is going to be 3 times 2 pi over 3. I'm putting this in the original function because I needed a slope and a point. This is my point. I'd be just left with 2 pi in the numerator. Cosine of 2 pi over 3, we said was negative 1/2. So I have 2 pi dividing by negative 1/2 is the same as multiplying by negative 2. So I get negative 4 pi. Negative 4 pi plus 4 pi. Be careful where your paper is laying around, because if people see this and they were like, I want to be that person's friend. So just be aware. This can make you so popular. You know what else can make you popular? More calculus. But these ones are a little bit better. I started out a little rough. So let's do another one. Find the derivative of each of these functions by applying the quotient rule. So the quotient rule is bottom times the derivative of the top. Don't forget parentheses. Minus top. I'm going to run out of room. I'm going to think outside the box. Or I'm going to write outside the box. Times the derivative of the bottom over the bottom squared. And then you know what you do with that answer? You leave it. The next one, f prime of x. Bottom times the derivative of the top. This is not your time to be a hero. This is your time to say, what was the derivative of tangent again? Do you remember? And if you're like, I don't remember. I think it was secant squared. Oh wait, I'm right. The derivative of tangent was secant squared. I don't have to do all that work again. So I'm going to say bottom times the derivative of the top minus the top. The derivative of the bottom is just 1 over the bottom squared. And then that's it. Leave it. Next one. You can try these too. Bottom. Bottom, make sure you put parentheses, times the derivative of the top. The derivative of sine is cosine. Bottom, derivative of the top, minus top. Derivative of the bottom would be the derivative of negative cosine, would be negative sine, so positive sine, over the bottom squared. And then leave it. If you wanted to simplify a little bit, you could. Okay, this one I'm going to say change only slightly. You see where it says 3 over and then minus 1 over x? You could do the quotient rule here, but I would say it would be much easier to do this and change that as x to the negative first power. Notice I'm labeling and you can tell this is clearly f of x. F prime of x would be the bottom times the derivative of the top. The derivative of the top would be negative times negative would be positive x, subtract 1 from the exponent. So I did bottom derivative of the top minus the top times the derivative of the bottom, which is just 1, over the bottom squared. And this is the only one we kind of have to rewrite, just because this would become x plus 5. I would want to rewrite any negative exponents. This would become 1 over x. There we go. Because then if you were using this, it would be easier to substitute. Okay, I don't actually want to do one more page yet. I could, but I'm going to start out with this tomorrow. The only thing is I'm going to say is you're going to learn this lesson tomorrow, but if you can simplify something first, so you see how this is a function right here, and it looks like you could factor out the numerator and the denominator, factor it first. You're going to save yourself a ton of time, but we'll get to this first thing tomorrow. But whenever you can simplify, simplify first. So I'm going to change this on the front of yours to 77 through 79, because I think you've probably had just about enough for today. Thanks so much for being awesome. I appreciate you. Thank you for working. I think you're great. Hope you're learning lots and you're finding this as fun as I am. I know it's not fun every day, but I hope it's bearable and life is good. Bye.